Section 7.4, Solving Rational Equations. So we have not solved yet, and in 7.4 we're going to learn how to solve rational equations. I want you to make sure that you understand you can only do these steps when you see the directions to solve. So this would be another note card that I would write on the front of the note card to solve a rational equation. Again, you could just write solve, because that's what you'll see on the test. But then go ahead and write this on the back of the note card so you know how to start it off. I love showing this section, but then I don't like showing this section because then people try and do this for every type of situation they have with rational problems. But you can only do this with rational equations. So make sure you have an equal sign if you're going to follow these steps. So to solve rational equations, the first thing you want to do is multiply every term by the LCD. So you still need to find the LCD, but you're not going to keep it. We did that with adding or subtracting, but not with solving. When you multiply every term by the LCD, this is going to eliminate your fractions. So you're really like, yay, I don't have fractions anymore. So then you're going to solve the resulting equation. Now either you're going to have a linear equation, which means you're going to have a power of 1, or you're going to have a quadratic equation, which means you'll have a highest power of 2. Why do we care? Because with a linear equation, we get variables on one side and numbers on the other to solve. But with a quadratic equation, we're going to have to make it equal to 0 so we can factor and solve. So know the difference between a linear equation and a quadratic. Once you solve, check your solutions to make sure they work back into the original equation. Why do you have to go back to the original? Because you're changing a rational equation into a linear quadratic. Well, we know with rational equations, there are some values we can't use. Those are the values that give us 0 in the denominator. So you got to be very careful with solving rational equations. So if your solution gives you a 0 in the denominator, this is considered an extraneous solution. So you cannot keep that solution. It doesn't work. So it's considered extraneous. So get rid of it. So before we start these problems, I always want you to have an idea of what your thought process should be. And what I mean by that is, first of all, how do we solve the problem? And then secondly, what values do we not want to get in the end? So that's going to be your little thought process. So you're going to have a little thought process on every single problem. And you're going to say, what values do I not want? Well, in the denominator, there's a 5 and a 2. So all numbers will work, so you don't have to worry about the thought, because there's never a variable in the denominator. So when you plug in, you're never going to get a 0 in the denominator. So you're good to go ahead and start the problem off. So how do we start the problem off? We find the LCD. So how do we do that? Well, we take our 5 and our 2, and we decide what's the first number 5 and 2 can both go into, and we know the LCD is 10. So we're going to multiply every term by 10. When we do so, what I like to do is go ahead and put parentheses on the whole thing and put 10 over 1. Now I'm going to show this step, but then I'm going to start skipping it because they cancel out. So 10 times x is 10x, and 1 times 5 is 5. 10 times x is 10x, and 1 times 2 is 2. And 10 times negative 9 is negative 90. Then what do? Reduce. 10 divided by 5 is 2. 10 divided by 2 is 5. And then we still have the minus 90. So that is why when we multiply by the LCD, we love it because our fractions go away. So if you need to show the step in between, great, but I'm going to start going from this step to this step. Then you have to look at this and say, is it linear or quadratic? Well, this is a linear equation because x's have powers of 1. So since they're linear, we're just going to get variables on one side. So we're going to go ahead and subtract over the 5x. And that's going to give me a negative 3x equaling negative 90. And then we're going to divide by negative 3. So x is going to equal 30. Now where should you check it? You should check it back into the original. 30 divided by 5 is 6, so we get a 6 on this side. 30 divided by 2 is 15, and 15 minus 9 is 6. So it does check out, so we know x equaling 30 works. Now really our check stage is more to make sure we don't get a 0 in the denominator, but you can certainly plug in and check your answer. Alright, so what is our thought process on number 2? Well, we do have an equal sign, so we know we're going to get rid of fractions by multiplying by the LCD. What's the one value we don't want to happen? Well, we never want the denominator to become 0. Well, this denominator will always be a 2. This one will always be a 2. But this one, we don't want y to be 0. because if I put a 0 here, I'm dividing by 0. Now what does this thought process mean? This is not an answer. This is just saying if I get this answer, I'm going to throw it out because I don't want that to happen. So again, this is just thinking. This is not our answer. So we need to find our LCD. So to find the LCD, we take our denominators 2y and 2. So our LCD is going to be 2y. So we're going to multiply everything by 2y. Again, we want to make sure our fractions disappear. So you have to take everything in each of the denominators the most number of times it appears. So I'll show this stage one more time. 2y times y is 2y squared over 2. Again, this is over 1, so multiplying straight across. 2y times 4 is 8y over y equals 2y times negative 7 is negative 14y over 2. And then we're going to reduce, so we end up with a y squared minus, we end up with an 8, and divide that out, we left with a negative 7y. So hopefully you're going to be able to go from this step to this step without having to show the in between. So now is this linear quadratic? Well, we have a square power, so we know it's quadratic. So we need to add over the 7y, and we're going to end up with y squared quadratic. We need to make it equal to 0 so we can factor and solve. Factors of negative 8 to add up to positive 7 would be positive 8 and negative 1. And then I'm going to set each one equal to 0. So this is why it was so important that you know how to solve well. And so y is going to equal negative 8 or y is going to equal 1. So I get two answers. And let's make sure we're okay keeping them. Were any of these answers in our thought process? No. So we're okay keeping those. Should we check them? Yes. But again, really in reality, we're just making sure we don't get a 0 in the denominator. If I plug in a negative 8, I'll get a negative 8 there. If I plug in a 1, I'll get a 1 there. So we should be good. All right. So I'm going to let you try number 3, and I'm going to give you the answer to it. So I'm going to circle that. I will give you some hint though that the LCD is the x plus 1 times the x plus 2. So your LCD is that. Multiply both sides by it, and you should end up with x equaling negative 6. What should have been your thought process? Your thought process should have been x should not be negative 1 or negative 2. Because a negative 1 would make this 0, and negative 2 would make that 0. Because I got x equaling negative 6, I'm okay. Alright, so let's look at number 4. So in number 4, we need to find our LCD first. I'll come over here to find our LCD. We have an x plus 5, we have an x plus 4, and we have an x squared plus 9x plus 20. So this is just going to factor into x plus 4 times x plus 5. So hopefully you can see that your LCD is the x plus 4 times the x plus 5. X plus 5 appeared, x plus 4 appeared, both of those appeared, so I had to take them once and once. So I'm going to multiply everything by x plus 4 and x plus 5. So it gets a little messy if you can't go from the step straight to either the linear or the quadratic equation. So that's why I'm going to skip the step in between. But hopefully you can see that if you multiply this times 2 but divide by x plus 5, the x plus 5s are just going to go away. And I'm left with 2 times the x plus 4. Plus, in the next one, the x plus 4s go away. So I'm left with 3 times the x plus 5. And the last term, because this factored into x plus 4 and x plus 5, both of those are going to cancel, so I'm just left with a 2x. So remember, this factored into x plus 4 and x plus 5. So what was our little thought process? What are the things we don't want to happen? Well, we never want our denominator to become 0, so we don't want a negative 5, and we don't want a negative 4. And again, those will be the same thing here because of the way that it factored. Don't decide if this is linear or quadratic until we distribute. So let's go and distribute, and then we'll decide if it's linear or quadratic. So 2x plus 8 plus 3x plus 15 equals 2x. So it looks like it is linear because x's all have powers of 1. So all I need to do is combine like terms, then get x's on one side and numbers on the other. So putting our like terms together, we have a 2x and a 3x that are on the same side. So we'll put those two together. That gives me a 5x. We have an 8 plus a 15, and 8 plus a 15 is going to be 23 equals a 2x. because if I bring over the 2x, everything is on the same side. I'm actually going to subtract the 5x to take it over to the other side. If you don't want to do it that way, you can certainly go ahead and subtract over the 2x and subtract over the 23. Then I'm going to divide negative in the denominator, so we put it on top. So x is going to equal negative 23 over 3. Are we okay to keep those answers? Yes. The only answers we didn't want were negative 5 and negative 4. I got negative 23 over 3. It can be kind of hard to check that answer, but again, we're just making sure we don't get a 0 in the denominator, and that answer is fine. Alright, so let's try number 5. X plus 3 over x squared minus 2x equals 10 over x squared minus 4. What's the first thing we should do? Find the LCD. So we're going to take the x squared minus 2x, we'll take the x squared minus 4, and we're going to try and find the LCD. So what are we going to do with this first denominator? We're going to take out an x and we're left with x minus 2. We're going to see this is a difference of squares, so this factors into x plus 2, x minus 2. So what is the LCD? Well, we had to take the x because it appeared once. We have to take the x minus 2 because it appeared once. And we have to take the x plus 2 because it appeared once. So now that I look at my LCD, I am covering everything in both of those denominators. So now that we have found our LCD, let's do our thought process. What's the thing we don't want? Well, we don't want any of these to make a 0. This would make a 0 if x was 0, so we're going to throw out a 0 if we get it. If we had a 2, 2 minus 2, so we got to take rid of the 2 if we get it. And the other answer would be a negative 2. So there's 3 values we don't want. We don't want 0, 2, or negative 2. Now these are not our answers. These are just things we want to make sure that if we get one of those answers, we don't keep it. So what do we do next? We're going to multiply everything by our LCD, which is x, x minus 2, and x plus 2. Now if it's easier for you, go ahead and write what this was as I factored. And keep this in your factored form down here so you can see what cancels out and what's left. So when I multiply by the LCD, what is the x plus 3 actually going to get multiplied by? Well, the x and the x minus 2 cancels, and I'm going to be left with an x plus 2. So it's x plus 3 times the x plus 2. On the other side, I have a 10 still, and the x plus 2 cancels, the x minus 2 cancels, so the only thing that did not cancel would have been the x. So if you can cancel these out in your head, you'll see what's left, cancel out in your head, see what's left, and write it out. Do not determine if it is linear or quadratic until we distribute. Well, x times x is x squared, outer gives me a 2x, inner gives me a 3x, and last gives me a positive 6, equaling 10x. So if you look at that, we see it's quadratic because we have an x squared. Since it's quadratic, we can find like terms, bring over everything to make it equal to 0. So I'm going to subtract the 10x, and I'm going to put all these together. And so what's that going to look like? You're going to end up with x squared. 2x plus 3x is 5x, but minus 10x is a negative 5x. We still have a plus 6. We had to make it equal to 0 because this was quadratic, so we need to factor and solve. So what are the factors of 6 add up to negative 5? That'd be a negative 2 and a negative 3, equaling 0. So then we're going to set each one equal to 0 and solve. So x minus 2 would equal 0, or x minus 3 would equal 0. So add over the 2, we get x equaling 2. And add over the 3, so x would equal 3. So now we look to make sure we can keep both answers. Remember, our thought process said, wait a minute, we can't use the 2. Because if I put a 2 here, 2 minus 2 is 0. So this gets thrown out and it is considered extraneous. Now, does 3 still work? Yes, it's okay to keep because it wasn't in our list. But what if 3 didn't work? Then we'd have to throw it out and call it extraneous. And then our answer would be no solution. However, x equaling 3 is okay to keep, so x equaling 3 should be our answer. So on number 6, I'm going to circle that for you to do. Your answer is actually no solution. So figure out why it is a no solution on this problem. I'll give you a hint on the LCD. The LCD is going to be x plus 2 times x minus 2. Make sure you do your little thought process to figure out what you shouldn't be keeping if you get it as an answer, and then go ahead and solve number 6. All right, so let's try number 7. First things first, let's find our LCD. So we have a y squared minus y, and that is just taking out a GCF. So we take out a y and we're left with y minus 1. We have a y squared minus 1, so that's factoring into y plus 1 and y minus 1. So what is my LCD? It's going to be the y, it's going to be the y minus 1, and it's going to be the y plus 1. So in our thought process, what are the things we don't want? Well, again, we don't want 0. So throw out 0 if we get it. We don't want 1 because 1 minus 1 is 0. And we don't want negative 1 because negative 1 plus 1 is 0. So we're going to not want to keep 0, 1, or negative 1 if we get those as our answers. If it's easier for you to see, go ahead and write the denominator as the factored form so that you can hopefully see what cancels and what is left. So we're going to multiply everything by the LCD, and our LCD is y, y minus 1, and y. So our LCD is y, y minus 1, and y plus 1. We're going to multiply and see what's left. So we have a y plus 3. What is it going to get multiplied by? Well, the y cancel and the y minus 1's cancel, and we're left with a y plus 1. Minus the 8. It had a denominator of y plus 1, y minus 1. So both of those cancel, but a y is left. And 0 times anything. We still have to multiply 0 times all of that, but the great thing is we just get 0. So then you're going to start folding that out. I'm going to let you finish this one and make sure you get an answer of y equaling 3. So see if you get the answer of y equaling 3. What would be the next step? Go ahead and distribute. When you do so, you get a y squared, and that means you're going to have quadratic. So you're going to need to make it equal to 0, factor, and solve. So it looks like you might have an extraneous solution on this one as well. All right, so let's try number 8 together. So on number 8, we're going to have to find the LCD, and it looks like it might be kind of a long one. So I'm going to try and do some more challenging ones with you. Hopefully you can finish the ones that we started. So first things first, we're going to take our denominators, y squared minus y minus 6. That's going to factor into y minus 3 and y plus 2. We're going to take the y squared plus 2y minus 15, and that's going to factor into y plus 5 and y minus 3. This is just that C method. And we have the y squared plus 7y plus 10, and that's going to factor into y plus 5 and y plus 2. So what is our LCD? Well, we'll start with the first one, y minus 3 and y plus 2. We'll see we also need to put in a y plus 5, and then the y plus 5 is there, the y plus 2 is there, the y minus 3 is there, so it looks like my LCD is that. So again, if it makes it a little bit easier to see, go ahead and write the denominators in the factored form so you can see what's left once you multiply. So I'm just going to write the factored form underneath. So we're going to take the whole numerator and multiply by the LCD, which is y minus 3, y plus 2, and y plus 5. So what is the 5 really going to get multiplied by? Well, the y minus 3 and the y plus 2's cancel, so it's just left with the y plus 5. Minus, what's the 8 going to get multiplied by? Well, it had the y plus 5 and the y minus 3, so it's going to be left to be multiplied by the y plus 2. And the 3 had the y plus 5 and the y plus 2, so it's going to get multiplied by the y minus 3. Again, we can't say if this is linear quadratic until we multiply it out. Now, what is our thought process? We want to make sure we don't get 0 in any of the denominators, so we would not want y to be 3, we would not want y to be negative 2, and we would not want y to be negative 5. 3 would give me a 0, negative 2 would give me a 0, negative 5 would give me a 0. So let's go and distribute now. 5 times 5, or 5 times y is 5y, 5 times 5 is 25. Be careful, you are distributing in negative, so negative 8y minus 16 is 9. Then what do we need to do? We need to combine like terms. So we're going to have some like terms to combine on both sides. So the 5y minus 8y gives me negative 3y. 25 minus 16 is a positive 9, and we still have 3y minus 9 on the other side. So I'm going to subtract over the 3y, and then I'm going to subtract over the 9. So negative 3 and a negative 3 give me negative 6y. Negative 9 and negative 9 give me negative 18. I'm almost there. I need to divide by negative 6, and y is going to turn out to be 3. So, what do I need to do? I need to make sure that I don't get a 0 in the denominator. My thought process said, wait a minute, can't use 3. Because why? If I plug in a 3 here, I get a 0 in this denominator, which isn't good. So actually this gets thrown out because this is considered extraneous. So what is going to be my answer? No solution. So again, I would definitely try these problems before going into your homework, making sure you can do the ones from the class notes and understand them well.